Hello again. Welcome to another lesson in Algebra 1. Today we are covering section 5.4 on standard form. So this is standard form of a linear equation, and we'll learn what that means in a few minutes. Okay, so the warm-up, if g of x equals 5x minus 2, then what is the value of g of x when x is equal to 3? So this time we know the input. So hopefully you stuck the input in for x. So this says what is the output of g? For input 3. So 5 times 3 minus 2 makes 15 minus 2, which is 13. Okay. Second question says, if f of x is equal to 0.5x minus 7, then what is the value of x? What value of x makes f of x equal to negative 2? So this time I know the output, I know the f, and I want to find the input, the x that goes with it. So I replace the f part with negative 2, and we solve for x. So we add 7 to both sides to get 5, and then we multiply both sides by 2 to make the decimal go away here, or divide by 0.5, and we get 10. So the input 10 will make the output negative 2. Okay, so there's my final answer there. All right, graph the linear function. So this is a review on graphing with point-slope form. So we're not trying to solve for y first because it's already in point-slope form. It's an easy way to graph. So we know our slope is negative 2/3, and the point comes from here and here. So remember, in point-slope form, it's really, let's write this in a different color here, y minus y1 equals the slope x minus x1. So y1 is 2. We have a subtraction in here already. So that's 2 for our y, coordinate of our point. However, this is x plus 4, so this is really x minus a negative 4. So the x coordinate is negative 4. All right, so first we put our point at negative 4, 2. So that's 1, 2, 3, 4 to the left and 2 up. Okay. Then we use our slope to get new points, and the slope is negative 2/3, so that's 2 down, 3 over. 2 down, 3 over, 2 down, 3 over. And we get a nice graph here. And we write y minus 2 equals negative 2/3 x plus 4 in parentheses. Number 4, write an equation in point-slope form of a line that passes through the point 2, negative 3 and has the slope of 2/5. So I'm going to write my equation for point-slope form. Y minus y1 equals 2/5 x minus x1. And remember, this is our xy coordinate. So we have x first and y second. So that's x1 and y1. And here's my slope. Okay. So I'm going to replace the parts in here that we need to. So y minus the y coordinate is negative 3. So minus negative 3 will turn into positive 3. And then we put the slope in, which was 2/5. And that was supposed to be an m here. So we replace m with 2/5. And then we do parentheses, x minus, and x1 is a 2. Okay, on page 2 we have the definition of standard form of a linear equation. Okay. Linear equations written in standard form are ax plus by equals c. Okay, where a, b, and c are real numbers, that means they have to be any number we want. And both a and b are both not 0. So one of them is allowed to be 0, but the other's not. Now by convention, we usually try to pick a, b, and c to be integers, and we try to pick a to always be positive. And we usually try to put the input variable first. So those are all conventions. You can just put decimals and fractions in them as long as you have real numbers. So no imaginary numbers here. Okay. Number 1, circle all the linear equations below that are in standard form. So the first one is in standard form. And I'm going to go through and name some a, b, and c so you get an idea of what's happening with those. So in this case, a is 1. B is 4, and C is 12. So we have the variable terms on the left side together. By convention, usually the input variable will come first. And we usually try to make the number in front of the input variable be positive. So we put a 1 there. Okay? So 1, 4, and 12. Now we use standard form already. We graph a lot of lines like this when we were graphing with intercepts. It's the easiest way to graph a line when it's in standard form. All right, number 2 is also in standard form, so we'll circle that one. And in this case, the A is 1, the B is 0, and the C is 4. So we're allowed to have either A or B be 0. In this case, they had B be 0, so there's no Y variable term. Okay. Number 3 here is not in standard form. The X and Y have to be on the same side. The fourth one here is in standard form. However, it's not written in very convention. Really, you should put the input variable first, and we should make it be positive. But in this case, the A could be -2, the B could be 9, and the C could be also 9. Okay, so we want to put the input variable first. So this one's not in normal convention. You really want to put the X variable first. Okay, number 5 here. Okay, not in standard form, although it could be really switched very quickly. You always want to put the variable terms on the left for standard form. So the A and X and the BY should be on the left side. Okay. So we could make this into standard form very fast because it's equal to, we could just flip it around. But it's not currently in standard form. And then our last one's definitely not in standard form. We have X's on both sides of the equals. So no good. So on the right side of the equals is supposed to be a constant, and on the left side should be your X and Y terms. And by convention, we usually put the input variable X first. We make all of the numbers be integers, and we try to keep the A value, the coefficient of the input variable, as a positive number. Okay. Number 2, write 2 equations in standard form that are equivalent to this equation. So here is currently an equation in standard form. It's got the X and Y terms on one side, the constant term on the other. Right now, the A is 2, the B is -6, and the C is 4. But we could change this by just timesing 1 by 2. So times the whole equation by 2, and we would get 4x minus 12y equals 8. That's one way. These 2 equations are equivalent. If I was to graph them, they would have the same x and y intercepts. For instance, for the first one here, if we cover up the y term, we divide it, we get the x-intercept of 2. Or if we cover up the y term here, we get the x-intercept of 2 also. So it doesn't matter that I times everything by something, as long as I keep it consistent. So I times all of them by something, so minus 12y. It'll be the same line. We could also have divided by any number we felt like, so we'll divide by 2 to get a second equation. X minus 3y equals 2. And notice if you cover up the y term and solve for x, so the y is 0, we still get an x-intercept of 2. Okay, so now, do we have to pick 2? No, we could have multiplied by 3 or 5 or 7 or whatever we felt like. Okay, number 3, rewrite each equation in standard form. So standard form, one more time, is ax plus by equals c. And we just need to get the x term in the front, then the y term, and then the constant term by itself on the other side of the equals. So in this case, I'll just subtract 4x to both sides. 4x plus 2y equals 10. Now this is okay for standard form, but by convention we like the input variable's coefficient to be positive. So I'm going to times everything by a negative, which will just flip all the signs on the inside. So it'll become positive 4x, and instead of plus 2y, instead it'll be minus 2y. Instead of positive 10, it'll become negative 10. All right, the second one. This one starts in point slope form, and we need to turn it into standard form. So I'll do my distributive property with the slope. So this will now become 2x minus 8. Then I'll move my x term over to the left side, so negative 2x plus y minus 3 equals negative 8. And then I will move the 3 over, so negative 2x plus y equals, add 3 to both sides will make negative 5. And same thing as the last problem. By convention, we'd like our input variable coefficient to be positive. So I'll times everything by a negative and do 2x minus y equals positive 5. All right, number 4, write the equation in standard form of a line that passes through the point 2, 3 and has a slope of 1, 4. So I wanted to go through this point. So I'm going to start with point slope form because I'm given a point and a slope. So that's the easiest form to begin with. So y minus the y coordinate, remember the y coordinate was 3. equals our slope, which is 1/4, and then x minus the x-coordinate, and the x-coordinate was 2. Right, so in this case, I just, same as before, I've got it in point slope form, I just change it to standard form. So y minus 3 equals 1/4 x minus 1/2, just distributing the slope. And then I'll move the x term over, so this will become negative 1/4 x plus y minus 3 equals negative 1/2. And then I'm going to add 3 to both sides. So negative 1/4 x plus y, and let's see, adding 3 is the same as adding 6/2, so this becomes 5/2 with a positive there. Okay. Once again, I want to get rid of the fractions here, and I'd really like the coefficient on the input variable to be positive. So to get rid of the fractions, I'm going to times by 4. That's the common denominator of our two fractions, 4 and 2. And then I'm also going to times by negative to make the input variable on the x term become positive. So this will become positive 1x minus 4y, and then negative 4 times 5 is negative 20, divided by 2 is negative 10. So there's our final answer there. All right, our last one on this page, write an equation in standard form of a line that goes through 3, negative 1, and 2, negative 3. So here I need to find the slope first. So I'll do the slope as a change in the y's, which is negative 3 minus negative 1 over top of the change in the x's, so 2 minus 3. This will give me negative 2 on top and negative 1 on the bottom for a positive 2. And then I'm going to write it in point slope form. So I'll use the second one. This is my y coordinate, so y plus 3, y minus a negative 1. Okay, and then our slope, and then x minus our x coordinate, so x minus 2. Don't forget this part right here is really y minus negative 3. That's why it becomes a positive. Okay. Now I'll distribute my slope. So y plus 3 equals 2x minus 4. And then I'll move my x term over to the left side. So negative 2x plus y plus 3 is negative 4. And then I'll move my 3 over to the right side. The constant terms all on the same side. So this will turn into negative 2x plus y equals negative 7. And then I like by convention to have a positive coefficient on my x term, so I'll times everything by a negative. So this will make positive 2x, negative y, and positive 7. All right, that concludes page 2. All right, on to page 3. Number 6, write the equation in standard form of a vertical line passing through the point 4, 2. What is the slope of the line? So I'm going to make a little graph just to remind myself about vertical lines. So here's my x and y axis. 4, 2 would be about right here. Okay. And we're supposed to have a vertical line, so that's an up and down line. And on all of these points on this line would be 4, 0, maybe 4, negative 4. Notice the x coordinate is all 4. So we have this. X is always 4. And it's already in standard form. The coefficients are 1 for the x, 0 for the y, and 4 for the constant term. What is the slope of the line? Remember this guy, so this is our first answer. What is the slope of the line? And it's undefined. Vertical lines do not have a slope. Okay? Slope is only for lines that are non-vertical. Number 7, find the missing coefficient in the equation of a line that passes through the given point and write the completed equation. So we want to figure out what the b is. I know all the other parts and I know a point. So this is really easy. Your point is x, y. So all we do is stick a negative 1 where x is, a positive 1 where y is, and then we solve for the coefficient b, that big one. So this will turn into negative 4 times, well, negative 4 times 1 is positive 4, plus b equals 7. We subtract 4 to both sides and we get b is 3. Okay, so we just need to, so here's what b is. That's one of our answers. It says write the completed equation. So our completed equation would now be negative 4x plus 3y equals 7. And if I was to plug negative 1, 1 into this equation, it would make a true statement. It would turn into 4 plus 3 on the left side. So I know that it went through the right point. All right, part B, same thing, except this time I'm looking for the A, and the B is a 1. Okay, so I plug in our x and y coordinates. So we have A times 2 plus 11 equals negative 3. Subtract 11 from both sides and we'll get 2a, a times 2 is just 2a, is negative 14, and then a is negative 7. So that's one of my answers, that's my missing coefficient. And then my other answer is to put the negative 7 in the a spot. So negative 7 plus times x plus y equals negative 3. There's my equation in standard form now. All right, our last question. T-shirts at the flea market cost $4.50 each, and shorts cost $6 each. You have enough money to buy exactly 12 t-shirts and 9 pair of shorts. Write an equation in standard form that models the possible combinations of t-shirts and shorts that you can buy. All right, so we want to know what can we get. We can buy exactly 12 t-shirts and we can buy exactly 9 pair of shorts. Okay, so if we have enough money to buy these things, 12 t-shirts and 9 pair of shorts, then how much money do we have? And that's what we want to know. All right, so let's see. 12 times the number cost of a t-shirt is $4.50, plus we had enough to buy 9 shorts, so 9 times 6. And I'll pull out the old calculator and calculate my total amount of money that I have here. So 12 times 450 plus 9 times 6 is 108. So this means we have 108 total dollars. All right, so our equation for this is going to be, what's the cost of the t-shirts? 450 times how many t-shirts I want to buy, plus the cost of the shorts, which is $6, times how many shorts I want to buy. That's supposed to be an S. And then equals 108. Okay, so let's just think about this for a second. If you cover up shorts and you make that be 0, okay, so cover up shorts, so we're letting S be 0. The T is going to be 108 divided by 4.5, that little equation there. So my T-intercept is 24. Okay, and then we could do the same thing. We let the T be 0 and solve for the S. So my S-intercept is going to be 108 divided by 6, which is 18. All right, so I need to graph the 18 and 24 on my grid. And obviously it's not going to fit if I go by 1, so it's going to require me to change the scale. So I'm going to go by 3s on both. Okay, so for the S-intercept, I'm supposed to have 18, and the T-intercept I'm supposed to have 24. So my S-intercept is 3, 6, 9, 12, 15, 18, right there. And my T-intercept is 3, 6, 9, 12, 15, 18, 21, 24, right there. Okay, and then I graph it. And that's the only piece of the graph I should do, because it doesn't make sense for me to buy a negative amount of t-shirts or a negative amount of shorts. Okay, and then it says list several possible combinations of t-shirts and shorts that you could buy. All right, so this chart's a little bit trickier. I'm going to list 3 of them. I'm going to list the really easy one. So we're going to do t-shirts and shorts. And we knew we had 12 t-shirts and 9 shorts. So I could have bought 12 and 9. Okay. I could also buy, let's see, I could buy 24 t-shirts and 0 shorts. Okay. Or I could have bought 0 t-shirts and 18 shorts. Okay, those were these 2 points right here and right here. And then any other combination that adds up to multiplies to 108, we could also pick. Okay, so these are 3. I said list several. Several is fine with me as 3, so I'm going to call it good. Okay, these are 3 combinations of t-shirts and shorts that I could buy. By the way, any place on this here, this little dotted line, that is whole numbers. You can't buy half a t-shirt or something like that, are fine. Okay. All right, so for follow-up, begin the Khan Academy coach's recommendation on converting between slope, intercept, and standard form. It's what we did for most of this notes. This will be due the morning after class, so I really suggest you get started on it. Hopefully finish it if you understood the notes, but if you're having trouble on it, you can watch the Khan Academy video or come back and watch this video again. I'll see you in class next time.